good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our AI Demo Day, brought to you by our headlining sponsors, Mistral AI and Google Cloud, and sponsors Aerospike, Precisely, Striim, PromptQL, and SAP. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI ecosystem for enterprise leaders. Today, we're excited to welcome hundreds of attendees from all over the world for an exclusive virtual event showcasing the most innovative AI solutions through concise 10-minute demos. At DSC, we value your time and have designed this event to provide impactful demos without any unnecessary fluff. Quickly identify solutions that meet your business needs and connect directly with the top leaders of pioneering AI companies. We're honored to hear from a distinguished group of experts today from some of the leading solutions in AI. Aaron Delp, head of technical marketing at Mistral AI. Haroon Dogar, senior product manager at Google Cloud. Shekhar Suman, senior solutions architect at Aerospike. Ruslan Sultanov, senior product marketing manager at Precisely. Edgar Bell, senior director of global technical alliances and solutions at Striim. And Rob Dominguez, engineering manager at PromptQL. Before we begin, a few housekeeping items. To make this feel a little more in person, we encourage you to add a photo to your profile and include your bio, LinkedIn profile, and any other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. Presenters may address your questions during their allotted 10-minute time slot or may respond directly in the Q&A and chat sections after they finish. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar. And finally, if you'd like to learn more about any of the solutions you see today or book a full demo, click on the calls to action below throughout our webinar from our sponsors. Now, without further ado, I'm excited to kick off our demo day with our first speaker, Aaron Delp from Mistral AI. Welcome, Aaron.
Hello, Brian. Can you hear me okay?
I can, and I'll turn the stage over to you.
Awesome, fantastic. So I'm going to share my window here. And Brian, if you don't mind, just let me know when you can see that okay. There we go. All right. So what I'm going to do is I'm going to go ahead and get started. So first of all, on behalf of Mistral AI and DSC, thank you everyone for your time today. Just wanted to say your time is valuable and we certainly appreciate that. And for that, I'm going to talk a couple of minutes today about creation of a couple different things. And I'm going to introduce you to Mistral AI Studio. AI Studio is our platform for agents, for workflows, for fine-tuning of models, for batch processing. And I'm going to show you how quickly and easily you can do exactly that. There's other aspects to the platform. There's observability in the platform as well, but it's kind of beyond the scope of the time we have today. So with that, what I'm going to do is I'm going to jump right into this. I'm going to go to agents. And the idea here is the playground is where you can create them and figure out, think of it as a big sandbox. Where are you going to create those and how are you going to create them? Then when you're happy with it, you put it in the agent library. So what I'm going to do here is actually, I have one that is, I created it actually for this demo because I was having a little bit of trouble with the speech to text conversion API that I'm actually going to show you later. Now, what I did though is this is running what we call Magistral. Magistral is our reasoning model, and I can give it temperature and tokens, and I gave it a bunch of information as well, and I'm going to go through that in a second. But what I'm going to do here is I'm going to pull up a prompt that I ran right beforehand, and the reason why I did that is, again, I want to go fast, and the reasoning model, it does a little bit of thinking. It does a lot of correction, if you will, as it goes to make sure the answers are accurate. But here's what I did. I basically told it it's a customer support specialist. I told it to be professional, and I told it to only really answer Mistral AI and API questions. So you notice here, I just said, hey, I want to do text-to-speech conversion for an API. I didn't say it's a Mistral API. I didn't say go look at the doc site, but I basically instructed this agent to only do all of that. So basically, I put all of that in, and then I ran through all of it and it spit out exactly what I needed. It says, here's how you set up your API key. Here's how you make the API call. If you want to do curl instead, you can absolutely do curl as well. And I was able to use this and the step-by-step analysis here to actually do one of the demos I'm going to be showing you in just a little bit. Now for the next part, I'm going to show you some other agents. And these are more just a little bit of fun and actually a little bit of practical as well. If you're not familiar with Mistral AI, we are headquartered in Paris. I'm traveling there next week, and I'm an endurance runner. I like to get outside and do long distance running. And so what I want to do is share, I want to run in Paris. That's all I said. Now it says here, based off of that, it's going to go look at the weather for that particular day. It's going to go do research on this. It's going to do web search, and it's going to put together a list of top 5 potential areas that I could go on a run next week while I'm there. And by the way, it gives me a description. It gives me the distance in both miles and kilometers. It gives me the elevation gain. It gives me whether it's a loop or whether it's an out and back. It'll also sometimes do single track or dual track. If you're a trail runner, that's super important to you. And it gives me a rating. So I'll definitely go and check one of these out next week. Now, the last one, this one's a little bit of fun. What I did here is we have another model here that we call our labs model. We have 2 labs models, and this one is called creative, and it's for exactly what it says: creative writing, narrative, and storytelling. So I'm going to say, tell me a story about a pirate with a peg leg and a parrot named Polly. Going to go ahead and generate all of this, and generates all of this on the fly. It says a story. It kind of does start to finish and has a little moral of the story. And oh, by the way, never underestimate a pirate with a peg leg or his parrot. Now, this is different every single time. So I ran this before. And the last time I ran it, it was telling me more about a story and haunted ghosts and other things like that. So get different responses out of this. A little bit of fun that I wanted to have with this. So that's agents and playground. Now, a big use in the enterprise is batch processing, specifically for OCR and speech to text conversion as well. So what I've done here is I've done a bunch of runs of audio transcripts and character recognition as well. Let's go look at what one of these would look like. So I just did the API calls. This goes and runs in the background. And oh, by the way, you might have upwards of 1 million documents that you want to process all at once. Lots of unstructured data out there in the enterprise. This is how you can go about doing something like this. So this is an audio transcription. This is just a speech in an MP3 I found on the internet. It went ahead and transcribed it all. It gave me the outputs that it wanted. And then what I'm able to do as well with these batches is kind of go in and do OCR. And this OCR, I took a Mistral paper and I said, go ahead and transfer that to text, which I did. But by the way, this isn't super entertaining, if you will, with a demo like this. And I understand that. So let's see what it looks like in real time. So I'm going to take Document AI, which is basically the exact same one, but in real time. So think of it as like almost single shot. And the idea here is I have a PDF. This PDF, the resolution isn't that great. The handwriting isn't that great. There's marks across text here that might be hard to read. And there's some checkboxes here. Let's go ahead and see what it does. And so what I'm going to do is I'm going to click run, and you'll notice this comes back decently fast of, okay, here's everything that's in the document. Here's everything that was written there. Here's the checkboxes with which boxes are checked. Here's the tables converted. Here is, for instance, this checkbox here. This one had writing, or lines across it, and it actually still recognized it and was able to do the character recognition on it, as well as the handwriting and the dates behind all of that. Now, there is the same way for the document OCR. There is a speech to text as well. I'm not going to go through it today, but I will tell you this, a little bit of a sneak peek. We actually had a brand new version of this model, version 2 of this model, drop today, and greatly increased the precision of it, greatly increased the capabilities of it. And even with this speech to text, what this was able to do earlier was only single voice. Now you have the ability to do multiple voices, identify multiple voices, go through, transcribe all of that, put it in text, put it in JSON, however you want to look at it. Now, I mentioned about fine-tuning and models. What I wanted to talk about that as kind of my last little bit here. The idea here was I took some of our models that take that one at the top. It may be a little hard to read, but this is Mistral 8B. So Mistral 8B is 8 billion parameter model built for on-prem and edge specifically. But I took it and I fine-tuned it and I made it afraid of ghosts. Why? Why not? It seemed like something fun to do as a quick little project. And so I took that off-the-shelf model, and if you prompt it with anything about what does it think of ghosts, it will say it is afraid of ghosts. You take the normal Mistral 8B, it obviously isn't going to. And I'll circle back around now back to this playground. So I made a custom model. I fine-tuned it. I can now, from this model picker, as I scroll down here, you'll notice I can now pick that model. I can take that model, I can add capabilities against it. Maybe I want to enable this model to run code. Maybe I want to be able to do image generation. Maybe I want it to do search functionality as well, to do call out libraries. All of this is able to be done very easily and quickly. And you kind of get this, you play around with it, you get it to where you like it, and then you go and create that in your agent library. Now, with that, I'm at a little over 9 minutes. I've actually been watching the timer and I want to stay within my time. So I'm simply going to close out by saying AI Playground is really the place to get up and running very, very quickly. Everything I've just shown you, there's documentation at the bottom. And I was able to create everything we talked about in no more than a few hours of work, including the fine-tuning runs for the customization of the models. With that, I'm going to end it there. We certainly appreciate your time today. And if this is interesting to you, please reach out to myself or really anyone at Mistral AI. Thank you very much for your time.
Thanks very much, Aaron. And if you guys enjoyed what you just saw, make sure you book a follow-up call with Mistral AI via that call to action below. Thank you, Aaron. Great presentation. And now I'm excited to welcome our next speaker, who is Haroon Dogar, who is Senior Product Manager at Google Cloud. So I'll welcome Haroon to the stage and turn things over to you, Haroon. Welcome.
All right. Thanks for the time. And because we have so very little of it, I'm going to jump right in. I'm going to show you our first-party agent capabilities through two different scenarios. In the first one, are you able to see my screen? Okay.
There we go. Now we're good.
Cool. So in this first scenario, we are a credit reporting company, and we've run some campaigns. So we have these tables available to us, the ad creatives, marketing campaign, et cetera. And you can see an example of those creatives. These are the 4 key ones. I'm going to jump up to creating a pipeline before I explain the problem we're trying to solve. So I'm trying to do an analysis of our problem, and I'm not really interested in the Python or the SQL, so I'm just going to put in a prompt to generate a pipeline to give me a table that I can use for my analysis. It's a really basic prompt. It's saying use this data set and create a table that has these fields as well as a new column for churned if churned is 1. Because the problem that we're trying to solve is that we've run this campaign and we have a lot more customers, but apparently it's not the right type of customers. We're losing money out of them because our customer acquisition costs are high, but they're all, not all, but a larger percentage of them are churning than we would ordinarily anticipate. So we're trying to figure out what's going on, what's driving that behavior. So the first thing I'm doing is generating this pipeline to generate that table. And it takes a couple of minutes, and it generates this structure where it's doing a 3-way join, and it creates that additional column. Ordinarily, and I would apply it and run it, but we're just going to go ahead and create the notebook. And in the notebook, I'm going to use our data science agent to put in a prompt for a more complex analysis. What I want to do here is to use that new table and to run an XGBoost model to predict the has churned column. But ultimately, what I really want to do is to run a SHAP analysis. So it gives me a plan of what it's going to do step by step. It's going to load the data, do the feature engineering, the model training, the SHAP analysis and visualization, then finish the task. So I'll accept that plan and run it. At each step, it's going to present me with my options. I can modify that code, or I can go ahead and run with it. It takes a few seconds for each of these steps. I'll accept and run this one. But in the interest of time, we're going to go ahead and jump ahead to a completed notebook. So in this completed notebook, you can see that it goes through and does all of those steps. And in the event that it encounters some type of an error, it will fix itself. So for example, this one threw a warning, and it corrected the warning in the next go through. But ultimately, we wanted to get to an answer to our problem about what is contributing to the churn. And here is the SHAP visualization. And it seems that one particular creative is contributing most, and that is the free dark web scan. So if I look at the 4 that were run in this campaign, we got the free dark web scan, the tax season promo ID, the monitor your score, and a generic brand. These 3 seem to be on the average the same. That shows me that those customers are the ones that are coming, using the service, and continuing. But this free dark web scan, it seems like that's a one-time use. So people are enticed by it, but they're joining up, using it to have themselves scan on the dark web, and then abandoning the service. So we have to do something with that creative, or with that functionality, and how we present it and promote it. Maybe it becomes a secondary or tertiary message within one of these existing ones. And all that analysis then is explained over here, not the specifics for that solution, but more about what is the actual contributing factor. And you can see that it's identified the same, the free dark web scan, and it has a summary Q&A and all the analysis of it. So that is the first one I wanted to run through. The second scenario, and let me switch tabs. The second scenario, we are a packaged goods company, a consumer packaged goods company. And the problem that we're having is related to our cash flow. So we changed our payment terms at the end of the year so that it went from net 30 to net 60. And we are seeing a growth in customers, but we are seeing an unexpected drop off in cash flow. We want to understand if it's related to our payment terms or if something else is going on. So I'm going to use now something that's available for a less complex analysis. The previous one was a SHAP analysis. Here we're going to do some forecast work. So we're going to use our conversational analytics. And you have the ability here to use your existing agents or create a new agent, but we're just going to connect to our existing data set and converse with that data set. So we'll look for the data set, connect to all of that data set, create a new conversation, and we'll politely ask it to show me the cash flow by month for full months only. So now we haven't specified which tables or anything, just the general data set, and we're asking it to figure it out. It'll take a little while. The problem we're trying to identify is, for the segments that we have, is there some different behavior that's happening? Is there some reason that the cash flow is down? Is it actually down? And so this first one is going to just show us the cash flow, and if we can see if there is a problem or not. So it gives us the summary, the table, the plot, as well as some of the insights and some suggested follow-up questions. We can see from the plot that our cash flow is fairly steady state until we change the payment terms. There was this trough, which is expected, this recovery, which is also expected, but then there's this subsequent leveling off, which is below the previous steady state. So we would expect this to be higher and closer to the peak post-recovery from that trough. You can imagine if you change your terms, everybody's going to start paying a little bit later, and so you'd see this drop off. But that recovery time also expected is going to show up, but then this should be at the higher level. So there's definitely a problem, and because, as you saw, each of these takes about 30 to 45 seconds to run, I'm going to go to an existing one in the interest of time and kind of go through the analysis. So we had this one that says, show me the cash flow by month for full months only. The next prompt was to show me the same by segment. And now we've got all the segments that we use, and we can see that the hospitality segment has been the one that's been remiss in, or most contributing to this cash flow drop, at least in the existing. So there's some insights there. Let's confirm some of those insights by looking at a prediction of our forecast for the next 6 months. And July is a little of an outlier here because it was a partial month of data. But the prediction here then shows us that we're also expecting this to continue, and hospitality being the problem. So one last analysis is, let's look at the days outstanding and see what's happening. And we can see that, okay, there's really just one segment that's fallen off the cliff. So it has nothing to do with our change in payment terms, but we do have a problem with something, maybe a macro that's going on with a particular category that changed at a specific point in time where they're just not paying their invoices. The hospitality industry is suffering, or tourism is suffering. So we have some insights there in how to proceed and move forward. So the key thing is, though, with all three of these, we were ordinarily things that might have taken a team of people to do over a couple of days can be done within a few minutes or a few seconds with these three different sources. So first, the data engineering agent for the pipelines, the data science agent for a deep analysis, and then for a different scenario entirely, the conversational analytics for a more basic type of an analysis. So thanks, and back to you, Brian. I hope I'm still on time.
You are. Great efficiency there, Haroon, and an excellent demo, so appreciate it. And if you liked what you saw in the audience, make sure that you click on that call to action below and book a follow-up with Google Cloud. Thanks very much, Haroon. And with that, I'm excited to turn things over to our next speaker, who is Shekhar Suman from Aerospike. Bring Shekhar on the stage. Welcome, Shekhar.
Hey, Brian, can you hear me all right?
I can. If you want to share your screen, you can make sure that works as well.
Just a second. All right, let me know when you can see my screen.
I see your screen, but not the slides. There we go. All right, and you're all set. I'll turn things over to you.
Perfect. Thank you, everyone, for joining in. I'm Shekhar Suman from Aerospike. We have talked a lot about agents and models and what we can do with them. I want to switch gears a little bit and talk a little bit about bringing those models and using those models to build real-world applications. Now, just a little bit of quick introduction about Aerospike. If you do not know, Aerospike is a NoSQL data platform. It's a key value store. It's known for its performance, for its real-time response times, for its very extremely high throughput, and so on. I'll not get a lot into that. Maybe I'll talk about it later if we get some time. But this application that I've built is a representation of what Aerospike can bring in while building an application using AI agents. So this is going to be a quick, it's an e-commerce application, and we'll be using an AI agent to first identify if a user that we have based on his previous features, if this user has a propensity to churn, or if he has a propensity to buy the products that he has added in the cart. So for that, we'll use an AI agent to call a classic machine learning model, which will be using features which are stored in Aerospike. After that step, the model then the agent then goes ahead and identifies what is the churn propensity. Accordingly, then using his demographic data, his profile data, and then he'll be making a call to a reasoning model, which would then decide what could be, or if any, nudge required to be sent to the user. What is a nudge? A nudge, it could be a text message, could be a WhatsApp message, could be an email, could be an in-app notifications, could be a coupon that the AI agent would decide that is needed for pushing this user beyond that line and actually going through that purchase. So it will first go through that process, identify what has to be done. Then again, it will call another AI model, this time a language model, to actually generate that text that has to be sent to the user. And that text would require some data about the user, some information about the user, his age, his preferences, and talk in the language of the user so that it can make the maximum amount of impact. All right, so let me quickly jump to the app itself. So this is the app that I was talking about. It's a simple app that I've built, and this runs Aerospike on the backend. Aerospike here is being not only used as a feature store, which serves as real-time machine learning model runs and calculating the churn prediction, but it is also being used as a checkpoint store for the agent. Now, when the agent runs, it goes through several steps, and each of these steps has some data that has to be stored. It stores the data and retrieves the data in each step as the model moves on. I'm using the LangGraph connectivity for this. I'm using LangGraph for creating those orchestration steps and so on. All right, so as soon as the user comes in here, he would see some products here and he would go ahead and add some products to the cart. Now, as soon as I go to the cart, this is where the AI model gets, or the AI agent gets triggered. This agent now is going through the process of identifying if, well, first fetching the data from Aerospike to run a machine learning prediction, get the churn, and then going through all the steps that I talked about. When that step is complete, it has identified that this user, well, is not, it needs a little bit of push to actually go through the purchase. So it went ahead and created a notification, an in-app notification in this case. And you can see the language has been generated by the model in itself. Shaker still chatting on MacBook Air. And this is based on the object which is in the cart and also based on a few previous data that I have fed to the model. Not only that, it has also been able to identify that we need to push him a little further. And it has made a tool call, which is a webhook in our application, to actually generate a coupon, which this user can use while checking out from this application. So this eventually becomes a real-time nudging mechanism for pushing users to complete a purchase. So we have seen agents work in various contexts, in contexts of generating images, generating text. But here, when we actually try to bring an agent to a real-world application, an application which serves millions of requests per second at times, the real engineering problems start to come in, right? The problems such as scale, the problems such as latency, the problems such as spiky traffic, the problems such as, well, changing usage patterns and so on. So coming back to my slides, inside this Reco engine, just as I said, it retrieved feature, it predicted the churn, it decided the nudge, it had some logic built in, it had a reasoning model which did that reasoning to identify what is the best message to be sent to this user and what could be the best mechanism to send this message to the user. It generates a nudge, sends out that SMS or sends out the WhatsApp message, and accordingly also maybe calls a webhook to create a coupon. Now, I just wanted to touch up upon the checkpointer part, where in each of these stages, as the agent progresses through the whole orchestration that we have built in, it saves a state, and that state could be multiple things. In this scenario, there are some user features. It could be the prediction that came out of the machine learning model. It could be the nudge that was actually decided to be performed. And then finally, sending out that nudge. And all of these is being saved on Aerospike implicitly by LangGraph in this scenario. Why do we need this? Is because, well, there is a multi-step process going on. And imagine this happening for millions of users. That's where things become more complicated. That's where you have to build in systems where you can make this thing reliable so that it can retry, it can come back to a situation where if something fails, it can retry from the previous checkpoint and so on. All right, so again, since I have just 5 minutes remaining, I'll get to the fact on why Aerospike for AI agents and why Aerospike is the perfect fit for AI agents. And that is only because of this technology that we call as hybrid memory architecture. Hybrid memory architecture enables us to store a large volume of data, terabyte and petabyte scale of data in SSDs, while the keys stay in RAM. Now, this allows us to run real-time inference, like allows us to store billions of features and fetch them at a consistent P99 of some millisecond, at P99 of extremely low latency. And most importantly, in use cases like these, where there is a large fan out, which means for each user who comes in and each time an agent is triggered, could be hundreds of DB calls that would happen to fetch several data while the agent progresses through each of these steps, and fetching these out and using it for various steps while making those LLM calls and so on. At that moment, you have another problem at hand, is that how can your system perform consistently when the scale increases to thousands and sometimes even millions of users per second? So that's where Aerospike excels, because it can not only handle a large volume of data, a terabyte scale of data, but also can promise you to give a consistent performance at scale, at any kind of traffic, at spiky traffics, at traffics where there are changing usage patterns and so on. So specifically for this scenario, for one user interaction, you saw that there was one user profile that was being fetched. Then there was the state that was being saved. Then there were features that were being fetched. And then again, there were several other calls that happened while we progress through the states of the agent, or while we progress the stages of the agent. And yes, that all resulted in various different kinds of database calls, and that had to happen at extreme low latencies and extremely high scale. And that's where Aerospike excels, to have a linear scalability, to have a performance which is consistent across any kind of scale that you can push this into. All right, was a very quick demo, a very quick introduction of what Aerospike is. One more thing that I would like to just talk about before I end this and give it back to the team is that there's a large ecosystem that supports Aerospike, specifically the connector ecosystem that we have built in, which helps us bring data from various different sources, such as Kafka and several other sources to Aerospike, so that we can integrate with the existing stack that you have and then support you while you build those AI applications and you bring them to production. Thank you.
Excellent. Thank you, Shaker. Excellent demo. And if you liked what you saw, make sure you book a follow-up with that call to action below from Aerospike. Thank you, Shaker. And with that, I'm going to turn things over to our next presenter, who is Ruslan Sultanov, who is the Senior Product Marketing Manager at Precisely. Welcome, Ruslan.
Thank you, Brian. Let me just quickly share my screen. Can you hear me okay?
I can.
Okay, perfect.
And I can see
Great.
the
Awesome.
slide.
Thanks again, Brian. Thanks to Data Science Connect for having me. I'm super excited to be here with you today. My name is Ruslan. I work in product marketing here at Precisely. And my goal today is really just to show you how we're helping AI apps stop guessing and hallucinating and start answering and producing results for you, especially when location plays a key role in the decisions you're making or you're helping others make. After my demo, I'll make sure to share helpful links in the chat so you can access various resources that I'm sharing with you throughout the presentation. So as a data integrity company, we're paying close attention to the stuff that actually breaks AI in production. Not model quality per se, but missing, inconsistent, or half-baked data. When 70% of your time goes into cleaning and prepping external data, and only 12% of organizations actually deem their data to be AI ready, the gap is exactly why so many AI projects stall out before they even begin to deliver real value. But then there's also another layer that often goes overlooked. Even when the data is technically clean, it is still missing context. And one of the most common types of missing context is location. Things like proximity, risk exposure, coverage areas, drive times, demographics, or what's actually around a given address. And this is where things get really fun, but also get very dangerous. Many questions that folks are going to be asking still continue to depend on where. Where's the nearest facility? Where should we expand? Where's the actual risk associated with an address? And if the model doesn't have trusted location context to support the response, in best case scenario, it will produce no answer. And in the worst case scenario, it will simply invent an answer. There's nothing worse you can possibly imagine. Also, most people, when they hear location data, they think about a point on the map, latitude and longitude, and that's not the only problem, and that's not everything that goes into it. The real value is everything attached to a place. Distance between that location and other locations, risks, accessibility scores, and what is actually happening around the location. That is why it's so important to get it right. So the obvious question is, how do you give AI this kind of location context without blowing up your architecture? And as many of you know, most AI platforms don't natively understand spatial data. I'm sure you don't want to deal with a new set of problems like writing spatial queries, performing complex joins, or learning GIS just to ship an AI feature. This is really why we've built Precisely MCP Server. With the server, you can ask a question in natural language. MCP will configure and figure out what location context is required in your particular use case. It will call our location intelligence APIs behind the scene and then translate the response back into something model can actually reason about. So let me just show you what this looks like in action. I'm going to just move here. So here we are going to start in Cloud Desktop, but thanks to the MCP model agnostic design, you can actually use it in any model of your choice. Most issues with address data, if you can believe, happen actually at the point of capture, when poor addresses enter your systems, and then the quality of operations continue to decay from there. So if we start with a simple request to complete an address, which you would most likely want to do in the first place, what you'll see in the response body here is not just a parsed complete address, but if you scroll, you'll also find out that we have assigned longitude and longitude and XY axis coordinates to this location during the geo-addressing process. Why it's going to be important is this helps streamline data enrichment, as you will see in a second. So you can read what Claude returns to you is the address with the location here. But if you ask to tell you more about this location, this is where the magic happens. Like I mentioned, we assigned XY coordinates, but we also assigned a precisely ID for this process. Precisely ID has an associated parcel, building, address, and point of interest that you can return during this process. So you can retrieve additional attribution, such as property data, different property details, neighborhood build-outs, places surrounding that address, places near that address, anything you need to know to accomplish your task. And as a result, you'll see you will be left with a comprehensive overview that is a lot more actionable than a single incomplete address at the point of entry that we have started with. So now let's say that you have some of your first-party data that you also want to leverage in your analysis. For that, let's jump into the location report project that I've created. Here, I have defined in the instructions that we are a site strategist, and we're looking for a report that's going to help us make better site selection decisions. We have defined our objectives. We have defined what information we need, but also we have defined the format in which we want this information to be presented to us at the end. And as a part of the project, we have also aggregated some consumer spend data that we want to use in this project, in addition to the location data that's going to be returned to us by the MCP server. In this case, you will get the same level of context as shown in the earlier example, plus the audience intelligence and consumer behavior data that we have presented in the file, the supporting document that we attached to. But it will also be presented in a way that we want to see, with a navy and gold theming that we requested, ready to be distributed or hosted. And as you can see, all the information that we requested and we got through the response is also presented here in this report that's a lot more accessible for a business user. Now, you can find all the different APIs you can call in our GitHub repository. I'll make sure to share the link with you so that you can follow and make sure you can access the MCP server on your own. The server itself is completely free to use. The only thing you'll need is a key and secret from Precisely. You will find it in the Precisely developer portal, to which I'll share the link as well. You can use our new AI assistant to find additional information about pretty much anything you want around our APIs. You can find information about how to generate API keys, as well as contextual information about any of the APIs that I have presented here today. So definitely make sure to use this as a resource. So the example I just showed was a site selection report, and mostly because it's just an easy way to show the breadth of information you can return in a single response. But the exact same pattern applies also to a lot of other use cases, like fraud detection, risk, logistics, site selection, anything you can possibly imagine, anything that relies on contextual and clean location data. And what really sets Precisely apart is the agentic radio location data with global coverage, pre-linked data sets that I'm going to talk about in a second here, and flexible delivery. So you saw examples of the MCP servers as well as our APIs, but we also can deliver most of our data as flat files using Precisely Data Experience. But the key thing is what we do is we transform addresses into join keys for richer context, not just for Precisely data, but also for data from our partners. We take data enrichment a step further through our data link program, which pre-links Precisely data sets to data from other leading providers such as Dun & Bradstreet, making it easier and faster to onboard and use data from multiple vendors to solve your unique business challenges. The recently joined the data link program is TomTom, who is a map and street data solutions provider. So if you're already using data from TomTom or any of our other partners, you can pair it with pre-linked complementary data sets from Precisely. and other partners to drive additional value for the use case that you're looking at. Because at the end of the day, this is really about reducing friction, less data wrangling for you, and more useful answers from AI. This is all I have for you today. I definitely invite you to check out the resources I'm about to share in the chat, and please reach out with any questions. Thanks again for having me, and back to you, Brian.
Outstanding. Thanks, Ruslan. Excellent demo. If you liked what you saw, make sure you book a follow-up with Precisely at that call to action below. With that, I'll turn things over to our next presenter, who is Edward Bell, Senior Director of Global Technical Alliances and Solutions at Striim. Welcome, Edward.
Thank you, and thanks everyone for having me. Let me go ahead and share my screen.
It's good. You're all set.
Perfect. Yeah, so I'm Edward, and I lead Striim's partner technology team. So we've been talking a lot today about, AI and how you can use it once you've already written data to some platform. But Striim is really here as a real-time data movement platform to enable you to access real-time AI. Oftentimes, what we've seen with AI models is one of the biggest issues is working with stale data. So Striim was actually founded by the founders of Golden Gate Software. If you're aware, they really pioneered the use of log-based change data capture as a new way to read from transactional databases to turn any production database into a continuous streaming data source. And as you'll see in the demo, how it works is you create these data applications where you drag and drop a source, drag and drop a target, configure your various connection properties, and you're good to go. So really those data pipelines enable the real-time AI from all of these disparate sources. But not only can you move the data, you can also transform, enrich, or process it in flight. So you can also use our included AI agents such as Sentinel and Sherlock, which enable you to, one, look at your data to see if there is any PII or any sensitive data that you might not want to move to the cloud, and two, act upon that data using Sentinel. So there you can encrypt, transform, or mask the data in flight, all within the Striim platform, really enabling you to reduce the time to insight on the target. So as I was mentioning, these included features within Striim AI within the product. These agents are called Sherlock and Sentinel, and I'll show those in the demo. One other thing I wanted to bring up, besides just the data movement aspect, is now really we're seeing companies need to ensure that their data is accurate. So recently we've released a new product called Validata, which its entire goal is to verify that your target data is in sync with the source, again, using an AI-based job framework. So this is a separate product from the Striim platform, but can be used in conjunction with it, one, to move your data to the cloud, and then two, to validate that it's been successfully landed on the cloud. And then just wanted to bring up a joint customer. Previously, we saw Google present. So one of our joint customers with Striim and Google is around VMO2. And they're using Striim and Google to do proactive network intelligence, really around detecting performance issues as they happen or even before they happen based off of patterns in network and customer behavior. So if you think about it from a technical use case, all they're doing is replicating data from Oracle to BigQuery. But that's enabling this really interesting business use case, really supporting the use of real-time AI. And with that, I know we don't have that much time today, so I will go ahead and get into a demo where I will show an example of replicating data from Oracle to BigQuery while also using our AI agents in flight. So how it works is, as I've mentioned, Striim is a platform. It runs either as self-hosted in a VM that you manage or as a fully managed SaaS. Regardless of how you deploy Striim, you'll arrive at this homepage, which is where you actually create these applications or data pipelines from a source to a target. So what we'll go ahead and do is we'll create an application. You can use a template-based wizard with all of these various connections, or we can start from scratch using this drag and drop interface. So we'll drag and drop Oracle as our source and set up the various configuration properties. So imagine here, if you're a financial services provider or a healthcare provider where you're replicating sensitive data to the cloud, you may want to protect that data and only migrate over a subset, or perhaps act upon that data. So once we've configured our Oracle source, we can just plug in Striim AI here in the upper right-hand corner, choosing either Sherlock or Sentinel. We'll select Sherlock, and then if we scroll down, we'll go ahead and click Run. And now what Striim did is actually looked at that table to see what it contains. We can see that we have a few sensitive data identifiers. And in this case, we only are using one table, but you can look into an entire schema. And what we can also do is download that report. So now you can take a look at this report, see which columns and what types of sensitive data your source contains prior to moving it. But now that you've decided what type of data that you want to replicate to the cloud, we can add in the Sentinel component. And what that does is you can specify within these specific fields what action you want to take upon that data while it's in flight. So this is all in memory prior to landing to the target system. So here we've selected, phone number and SSN. We want to mask completely. And then we'll just add a new target component to write out to BigQuery. So Striim can replicate data from on-prem to on-prem, from on-prem to the cloud, from cloud to on-prem, really any sources and targets that you can think of, although typically replicating from transactional databases to cloud data warehouses for years at a time, where we see that customers don't necessarily want to get rid of their transactional databases, but they want to split their transactional and analytical workloads. So now all we're doing here is configuring our target. In this case, it's BigQuery, and we can choose if we want to run in either append only or merge mode to either apply those events or just run as an audit log. You can even parallelize this process to performance tune and increase the speed of these applications. We actually have a joint blog published with BigQuery where Striim is the fastest data ingestion tool into BigQuery. We had a 160 gigabyte Oracle redo log being generated on the source, which was replicated to BigQuery with less than 2 seconds of latency. Here within this demo, all we're doing is showing this data on our source, where you can see all those phone numbers, address, and SSN, which we want those to be masked on the target. In this case, we don't have any data within BigQuery. Now we'll go ahead and start the Striim app. You can see that those are masked now within this preview window. And then we can validate that by going to our target BigQuery instance. So here, when you were seeing some of those neat BigQuery features previously, you can think of Striim pulling in data from all your various sources into BigQuery to enable those AI use cases. And then within Striim, there are quite a few different monitoring aspects. So there's an entire monitoring suite, so you can ensure that everything is running smoothly. We can dive into that app that we were working with earlier, take a look at your sources, take a look at your targets, make sure the amount of events in equal the amount of events out, and also even look at things such as end-to-end lag where Striim computes the amount of time that it takes from reading a record on the source to writing out to the target. And what you can also do is create alerts and connection profiles. So connection profiles allow you to easily use a single source or target across multiple data movement applications. And alerts enable the ability to create alerts for actions such as something going on the infrastructure that Striim is running on, or an app that we were working with. So say that Oracle, the BigQuery app that we were working with, if the event count, the Oracle reader's event count was 0, you can receive such as a Slack or Teams alert for that behavior. So that just makes it easier to manage Striim so you don't have to constantly be looking at the UI. Can also configure users and roles. So you can have certain users with application creation privileges and other users with only viewing privileges. And then one last thing I wanted to show you is the console. So if you wanted to do everything that we did via the command line, you can. But that command line is also exposed here within the UI, where there are certain metrics that aren't exposed in other pages of the UI accessible here. And then each Striim application is also backed by what we call a SQL file. So this is how you can really create a programmatic approach to database migrations and replications. So here you can see this is really simple syntax. And what we've seen customers do is really create sort of a replication factory where they'll create a script to create these applications, store them in your CI/CD pipelines, and then from there, you can use a REST API around Striim to manage, deploy, and run those Striim applications. So this was a pretty representative demo of what a typical Oracle to BigQuery pipeline would look like with AI in the pipeline, as well as enabling real-time AI once that data lands on BigQuery. So that's about it that I have for today. Again, appreciate having me on. Thanks.
Great. Thanks, Edward. Excellent demo. And if you liked what you saw, make sure you book a follow-up call with Striim via that call to action below. With that, I'm excited to turn things over to our final presenter, Rob Dominguez, who is Engineering Manager at PromptQL. Welcome, Rob.
Thanks, Brian. Goatee's looking good today. Appreciate it. I'm not going to say that we saved the best for last, but I mean, we are here, so I'll go ahead and put it up there. Let me get my screen share going. Hope everybody's doing well. All right, cool. Let's see. This is, I think, the third time that we've been here with Data Science Connect, and we really appreciate the opportunity to always be in these calls with you folks, and thanks for sticking around to the end today with us. What I want to talk about today is this concept of what we really call scaling accuracy. In PromptQL, we kind of frame ourselves as the AI analyst with enterprise-grade accuracy, as you can see there from the title. The very first thing that I want to do before we dive into a demo is just kind of ask this question and ask everybody to process it, yourselves. If you want to throw it in the chat, you're more than welcome to. But just posing this to you, what's worse, an AI tool that says, I don't know, or one that gives you the wrong answer? And that's really kind of fundamental to what we at PromptQL do, especially when it comes to enterprise data. And I'm hoping that you would be in the camp that says wrong answer is worse than, signaling a lack of understanding or a need for more clarity. There was a meme that was passed around internally recently. If anybody's a Lord of the Rings fan, this one really resonated with me. You have Bilbo there saying, why shouldn't I keep it? And, of course, I'm sure anybody who's used a large language model before, whether it's from OpenAI or Anthropic or anybody else for that matter, has encountered these words, you're absolutely right. Easy to kind of push these models in certain directions. What I want to look at today is how we solve this problem of ensuring that the context and the understanding of your data matches what is actually true, so to speak. So let me actually jump into our product real quick. For anybody that's used any of these large language model tools before, any of the Frontier Labs or just about anything else for that matter, you should be familiar with this conversational interface that we see in front of us right now. Just real quick, I'm giving a high-level overview. We can see that we can ask questions here. We can attach documents or files if we want to. We can even tag people, which we'll see a little bit more about in just a moment. We can see our history of all of our chats over on the left-hand side as well. What I want to talk about is really that accuracy piece. So you can see that earlier I asked this question of what is our GM so far this quarter? Now, on the engineering side, there are some things that I am aware of when it comes to the business, and there are some things that I'm not aware of. A lot of these acronyms and terms may not be super clear to me, and they may not even be super clear to a large language model either. One of the things that's unique about PromptQL is the very first thing that you'll get after you ask a question is going to be the system's interpretation of your question itself. And there's a couple of visual indicators that we can see here. We see that this query understanding has been analyzed for the question that says, what is our GM so far this quarter, just like we have up here. But again, there's two visual indicators here. We have this blue piece for GM and this red piece for quarter. What PromptQL is doing right now is saying, hey, I've broken apart this question that you have, and I understand part of it, but I don't understand all of it. So I'm going to continue forward with a couple of assumptions in mind. And we can see right up front what those assumptions are. It's going to go ahead and guess that essentially this quarter resolves to 2026 from January 1st through March 31st. And it's going to have to do that essentially for those dates. You can see that we have this exploder here for wiki content, or this expansion area. And there's actually a semantic layer where we can go in a second. We'll see more information about this, where we can define these things that are important and contextual to our business to help a large language model understand exactly what we're asking. If I scroll down, there's a few things that if you've seen any of our presentations before, if you've seen anything about our product, you'll probably be aware of. We give you a query plan right up front that's going to be put in plain language explaining how the system is going through all of your different connected data sources throughout all the semantic context and trying to figure out what the best answer is to pull that data in to answer your question. If I'm a more technical person, I can actually expand each part of this. And essentially what's happening under the hood is there's a small Python executable and SQL being run on the data itself. But if I'm a non-technical user, I don't ever have to see this part. I can just see essentially kind of these steps that are happening and know that they're happening in sequence along the way to be able to answer my question. Now, PromptQL goes ahead and gives me an answer and says, hey, for Q1 2026, so far gross margin is 44.1%. And it'll give me a little bit more analysis. I can expand an artifact pane over here on the right-hand side if I want to. That'll show me more details, either in table format or in a visual format that's very appealing, using a new tool that we have called our UI programmer that will actually spin up a small independent web application that visualizes the data and does it in a really great way for creating essentially on-the-fly dashboards. What I want to point out, though, are a few things here in this first part of the response. So it's letting me know again, hey, here's the key assumptions that I made. And it's also citing the different pieces of semantic information that I have from our wiki layer. And this is where we can go in and actually define information, again, that's relevant and important to our business. That could be acronyms, that could be terms, that could be formulas that we use, or it could even be the dates that we have, for example, the financial year itself or the quarters. Now, again, being from engineering, I may not know exactly what these dates and numbers are. So instead of having to go to Slack or any other tool for that matter and pay my coworkers to come in and tell me, hey, what is the financial year? What are our actual dates? I can actually do it inside of the product itself. So I can tag my coworker Adam here and say, hey, remind me when Q1 starts. He'll get a notification in his platform of choice, again, whether that's Slack or anywhere else for that matter, that will actually bring him into this exact conversation. He sees that I've asked him this question. He says, let me find out real quick for you. And then he responds to PromptQL. So we now have a multiplayer conversation thread happening here. PromptQL sees that it's been tagged and it has this new information that's addressing the assumption that it had earlier on. So we'll go ahead and see that it's actually going to rerun the information rerun the query rather, based on this new information. I'll tell it, yep, go ahead and rerun. It gives me my new answer, which is awesome and more accurate. Here's my absolute favorite part though. I don't want to maintain that semantic layer. Clearly, Adam doesn't want to maintain it because he hasn't actually done it in the first place. What PromptQL can actually assess and understand is there are next steps to be had. So instead of having a semantic layer that becomes stale over time and ends up becoming out of date, just through having conversations inside of PromptQL, you can actually actively maintain and improve that semantic layer itself. So you can see that there's a few suggestions that it's made here to our semantic layer. Hey, we should add these new pages for fiscal quarter, what Q1 is, or what public sales daily means, or we can actually update. So I'm actually going to go ahead and just say review because I'm curious what this looks like. As the subject matter expert or as the person involved in the conversation, I'm actually going to get a diff view that will show me what things were like before and what things will be like now. All I have to do is hit save changes, and that'll automatically be available. So the next time somebody comes in and asks a question that has fiscal year included here, or quarter included for that matter, this will be 2 blues instead of 1 blue and 1 red. So again, you're actively improving your semantic layer as you move through just having conversations with your teammates and with PromptQL itself. So the thing I want to leave you with today is just this question of the AI initiatives that you have within your organization. Are they leading towards adoption, or are they leading towards obsolescence? That's kind of the big question now. If you want to think about which direction these things go, the red line is where we don't want to be. That's the obsolescence. That's our current AI solution dying away. It's dying because not that it doesn't have access to information, but it doesn't have access to that tribal knowledge and context that's so important and so relevant for large language models to get questions, or rather answers to questions, right. And what we see instead is through PromptQL, we have this flywheel where the system signals its uncertainty. We bring in people that do have that context and do have that knowledge, can share it with the system, and then it automatically becomes incorporated with human oversight into the semantic layer itself, so that every time we have a conversation, we improve. Brian, I'm going to go ahead and turn it over back to you.
Excellent. Great demo, Rob. Thanks for joining us again. Always a pleasure. And if you liked what you saw, make sure that you book a follow-up call with PromptQL in that call to action below. And with that, that concludes our Q1 demo day. So I want to thank all of you for joining us. If you missed any of this demo day, or you want to rewatch anything, the recording will be available at this same URL just a few minutes after the webinar concludes if you refresh your screen. And we'll also send out a link to the recording on our YouTube channel tomorrow. So thank you again to all of you for being with us, to all of our presenters, and to all of our sponsors, our headlining sponsors at Google Cloud and Mistral AI, as well as our sponsors at SAP, PromptQL, Precisely, Striim, Aerospike. We'll see all of you again next time. Thank you.